Good afternoon, my dear students. In this video clip, now I want to discuss about motion of the particle in two dimension. Motion of the particle in two dimension. It means the motion of the particle in a plane surface. Motion of the particle in the plane surface. Before going to that explanation about the motion of the particle in two dimension or in a plane surface, I want to request to all the students, all my dear students, you are become a subscriber for our physics channel. I request to everybody, yes, you become a subscriber for our physics channel. You press that subscriber button and you press that bell button, you become a subscriber for our physics channel. Yes, okay. I hope all of you become a subscriber for our physics channel. Yes. Now, you see a motion of a particle in a plane surface. Two-dimension motion. Two-dimension motion is very difficult to study compared to the motion of the particle in one dimension. Once a particle move in a two dimension, it change with the two coordinates. Change with the two coordinate. It depending upon the particle is moving in which plane surface. ಯಾವ ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ನಲ್ಲಿ ಬಾಡಿ ಮೂವ್ ಆಗುತ್ತೋ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. If the particle is moving xy plane, there is a change the coordinates x and y. ಅದು ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ xy ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ನೊಳಗೆ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ ಆದರೆ ಬಾಡಿ ಮೂವ್ ಆದರೆ ಅದರಲ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಕ್ಕಂಥ ಕೋಆರ್ಡಿನೇಟ್ ಎರಡು, ಒಂದು x ಇನ್ನೊಂದು y. Suppose the particle move in a yz plane, there is a change in the coordinates y and z. If the particle move in a xz plane, at that time change the coordinates x and y, because it covers the distance both along x axis and also y axis. ಯಾವಾಗ ಪಾರ್ಟಿಕಲ್ xy plane ಮೂವ್ ಆಗುತ್ತೋ, ಇಟ್ಸ್ ಮೂವ್ ಇನ್ xy plane, at that time change the position along x axis as well as along y axis. At that time you got the displacement in x axis as well as in y axis. At that time you got the velocity along x axis as well as along y axis. It is very difficult to study the motion of the particle in two dimension compared to one dimension. ಇಲ್ಲೇ ನಾವು ಎರಡು ಕೋಆರ್ಡಿನೇಟ್ ಚೇಂಜ್ x ಮತ್ತು y, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎರಡು ಕಡೆ ತಗೋಬೇಕು. ಅಲಾಂಗ್ x ಆಕ್ಸಿಸ್ ತಗೋಬೇಕು, ಅಲಾಂಗ್ y ಆಕ್ಸಿಸ್ ತಗೋಬೇಕು. ಓಕೆ, ನೋ you have to take the orthogonal vectors. What are the orthogonal vectors? I cap, j cap, k cap. I cap is the unit vector. I cap is the unit vector along x axis. J cap is the unit vector along y axis. K cap is the unit vector along z axis. But here you have to take only on xy plane. Therefore, you come across that is the two unit vector I cap and j cap only. Let us the particle is moved from one point to the another point in xy plane. It is moved from one point to the another point in xy plane. It is the change the coordinate both x and y. At that time, position vector for any position vector. Now it is you take the one origin. Origin is there here. Position is there here. This is position vector r1. Another position vector is r2. We express the position vector. You express the position vector in xy plane with the help of two coordinates x and y. If it is 3 dimension, different thing. X, y, z. You take all the 3 coordinates. Example: a particle throw in a space, it is move in a curved path due to the effect of gravity. It is a 2-dimensional motion. Rotating fan is the 2-dimensional motion. A particle move in a circular path, 2-dimensional motion. When you take the car or bicycle turn on right side or left side, that is on the surface of the ground, it is a 2-dimensional motion. 3-dimensional motion: flying bird, flying butterfly, flying mosquito, zigzag pattern like this. 3-dimensional motion. 2-dimensional means it is moving in a particular plane surface. The body particle is moving like this in a particular plane. That is the board, on a board plane. Then it is said to be 2-dimensional motion. Now you take at the different positions, you express the position vectors. Now, when a particle moves in 2 dimensions in a particular plane, at that time, how you take the position vector? How you take the displacement vector? How you take the velocity vector? You express the displacement vector easily, but in the case of velocity vector, you come across there are 2 points: average velocity and instantaneous velocity. And again, when a particle moves with the 2-dimensional motion, at that time express the acceleration. Again, we express the acceleration, average acceleration, instantaneous acceleration, like that. Now, when I consider a particle is moving in a 2-dimensional motion, it is in a particular plane, xy plane. Then we express the position vector, we express the displacement vector, we express the velocity vector, now the average velocity and instantaneous velocity. This is very important. In beginning we have already know this resolution of a vector. Resolution of a vector. A vector split up into 2 vector components. A vector is split up into 2 vector components. They are perpendicular to each other. This is the vector. This is said to be Vx. Another one is said to be Vy. 2 vectors. Now this is Vx I cap. This is Vy j cap. 2 components split up into 2 components. This is called resolution of a vector. Resolution of a vector point is very important. At that time, vector v is equal to, you have to write vector v is equal to vx into I cap plus vy into j cap. Then v is equal to under root of vx square plus vy square. Then direction tan theta is equal to vy divided by vx, like this. Now we come to the position vector. Now this is xy plane. This is the ox. This is oy. This is ox, oy. Let us take the point P. Point P is in the xy plane. Point P is in xy plane. Now it expresses its position with the help of 2 coordinates x and y. You express the position of this point with the help of 2 coordinates x and y. And with the angle theta along ox, along oy. Yes, it is the position vector. This is vector r. The position vector r. Suppose you take the x, vector y, vector z. It is only 1 dimension. Suppose you represent the vector r. Either it may be 2 dimension, either it may be 3 dimension. Here you take 2 dimension. Now the vector r is equal to x I cap plus y j cap. X and y are the coordinates for the position P. Then you express the position vector. That position vector r is equal to x I cap plus y j cap. You express like this. Position vector. You write the vector r, then position is expressed in 2 dimension, or you said 3 dimension. You express the x, y, z individually, s, d like that, it is 1 dimension. Now, this magnitude, its magnitude, r is equal to under root of x square plus y square equation number 2. When a particle move 2 dimension motion in a particular plane, you express the position vector. You express the position vector r is equal to x I cap plus y j cap. Then its magnitude r is equal to under root of x square plus y square equation number 2. Then direction is tan inverse of y by x. According to this one, opposite side divided by adjacent side x, y by x. This is about position vector. Position vector is always represented by vector r in 2 dimension and 3 dimension. If it is 2 dimension, it is expressed in terms of x and y in xy plane. So what is the xz plane? X and z. Z again it becomes into k cap, z into k cap. In yz plane, y and z, like that. That is a 2 dimension. Now, displacement vector. Displacement vector. When you got the displacement? Only when the particle changes position. Changes position. How you define the displacement? Change the position of the particle in a particular direction is called displacement. But we express the displacement in 2 dimension motion. 2 dimension motion, very important. There are 2 positions. One of the position is expressed in terms of x and y. Another position is also expressed in terms of x and y. Now see here. This is x axis. This is y axis. Okay? There are 2 positions, position P1 and position P2 in xy plane. Now position P1 is expressed in terms of x1, y1. Position P2 is expressed in terms of x2, y2. When a particle moves in 2 dimension, there is a change the coordinates both x and y. Initial position for x axis x1, now it is x2. Beginning along the y axis y1, it becomes y2. We express the coordinates, both the coordinates x and y. Position vector, this position for position P1 x1 y1, for position P2 x2 y2. Now the position vector for the first position is vector r1. Vector r1 is equal to x1 I cap plus y1 j cap. Similarly, position vector for P2 position, vector r2 is equal to x2 I cap plus y2 j cap. Yes. Now change the position. Change the position. Displacement vector from this point to this point. Displacement vector. This is vector r2 minus vector r2. Vector r2 minus vector. Yes. You come to the point. Displacement vector, that is vector r2, the position vector for the position p2. This is x2 I cap plus y2 j cap. And for position P1, x1 I cap plus y1 j cap. Minus is there. I cap is common here. x2 minus x1. x2 minus x1 into I cap. Plus y2 minus y1 into j cap. Now x2 minus x1, it is displacement, distance covered along x-axis. Delta x. y2 minus y1, distance covered along y-axis. I have said displacement. Then displacement in two dimension, particularly in xy plane, that is delta r delta is equal to delta x I cap plus delta y j cap. This is equation number 3. Now this is the displacement vector in the xy plane. This is displacement vector in particular plane, that is xy plane. Now it is also given by vector delta r is equal to delta x, vector delta x plus vector delta y. If you want the magnitude of the displacement vector at that time, delta r is equal to root of delta x square plus delta y square. Direction is delta y by delta x. Similar to how to take apply this. What's this point? This is said to be displacement vector. What is the direction of the displacement vector? In this direction. The direction of displacement vector from P1 to P2. In the direction that is P1 to P2. Now see here, this is position vector. This is the equation for the position vector. If the equation for the magnitude of the position vector, it is the direction of the position vector. Now come to this point. This is the expression for the displacement vector, and it is the equation for the magnitude of the displacement of the vector, and it is the direction of the displacement vector. That is, here I have to write theta is equal to tan inverse of delta y by delta x. Now you come to the point velocity vector. When you go to the velocity, there is a change in the velocity with respect to time. Change in the displacement with respect to time. It means change the displacement per unit time. This is called velocity. Again, you take the velocity, average velocity, and what is you say instantaneous velocity. While average velocity is totally ಇನ್ನೊಂದು instantaneous velocity. Once you change the position, this is the xy plane. How to take again xy plane. This is x axis, this is y axis. Carefully observe this. Now this is the direction of the displacement. This is the direction of the displacement. Yes, change the position from P1 to P2. Vector R1 is the position vector for the position P1. Vector R2 is the position vector for the position P2. If there is a change in the position, this is the direction of the displacement. Once direction of the displacement, definitely along the direction of the displacement, there is a direction of the velocity. Direction of the velocity ಯಾವಾಗಲೂ along the direction of the displacement ಇರುತ್ತೆ. ಅಂದ್ರೆ ಇದು displacement direction ಅಂದ್ರೆ ನಾ ಹೇಳಕತ್ತೀನಿ average velocity. Average velocity is equal to displacement divided by time. Displacement along x-axis, displacement along y-axis divided by time. Separate ಮಾಡ್ತೀನಿ. Average velocity is equal to displacement along x-axis divided by time into I cap. Displacement along y-axis divided by time into j cap. Now this is PAV is equal to PX average Vx I cap plus average Vy j cap. Andre average velocity is equal to in two dimension average velocity along x-axis, average velocity along y-axis. I cap. Now here vector the average velocity along x-axis is equal to average displacement along x-axis divided by time. Average velocity along y-axis, average displacement along y-axis divided by time. X ಬರೆದರೆ one dimension, including both the dimension x and y is a two dimension. Delta r ಯಾವಾಗ ಬರೀತೀವಿ? Delta r indicate two dimension motion. ಇಲ್ಲಿ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ delta t tends to 0 ಇಲ್ಲ. Delta t tends to 0 ಇಲ್ಲ ಅಂದ್ರೆ for example that is delta t is 60 about 30 second. Delta t is about 30 second. This is about 2 meter like this. 2 meter like this. It is not equal to 0. Delta t is not tends to 0. Delta r is also not tends to 0. At that time you got the average velocity. ಏನಾದ್ರೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಬೇಕಿತ್ತು ಅಂದ್ರೆ ಅಂಡರ್ ರೂಟ್ ಆಫ್ px bar whole square plus py bar whole square. ಏನಾದ್ರೆ ಆಂಗಲ್ ಬೇಕು. This is the expression for the average velocity. Average velocity along x-axis, average velocity along y-axis. ನನಗೆ ಡೈರೆಕ್ಷನ್ ಬೇಕು. theta is equal to tan inverse of py average divided by px average multiplied by. This is about average velocity. This is about average velocity. Now, instantaneous velocity. When you got the instantaneous velocity, when delta r tends to 0, tends to 0 ಅಂದ್ರೆ delta r tends to 0 ಅಂದ್ರೆ 2 ಐತಪ್ಪ. 2 ಇದ್ದದ್ದು 0.2, 0.2 0.02, 0.2 0.002, 0.002 ಇದ್ದದ್ದು 0.00002 like this. Not equal to 0 but tends to 0, tends to 0, tends to 0. Time 30 second. 30 become 3, 3 become 0.3, 0.3 become 0.03, 0.03 become 0.003. Tends to 0. Tends to 0 means delta r equal to 0, tends to 0 means it becomes 0.2. Delta r becomes 0.2, very small point. It becomes very small point. Very small point. This is the direction of the instantaneous velocity. Delta t tends to 0 ಅಂದ್ರೆ ಹತ್ರ 0. ಈಗ 2 meter 0.2, 0.02, 0.002, 0.0002, 0.00002 tends to 0 but not equal to 0. ಅದೇ ರೀತಿ delta t 30 second 3, 0.3, 0.03, 0.003, 0.0003, 0.00003 like this tends to 0 but not equal to 0. At that time for the instantaneous velocity. It means limiting value of average velocity. Limiting value. Now this instantaneous velocity can be represented by this is for instantaneous velocity. That is limit of delta t tends to 0. Delta r divided by delta t, it becomes dr by dt. Delta ಹೋಯಿತು, d ಬಂತು ಸ್ಮಾಲ್ ಲೆಟರ್ d. ಸ್ಮಾಲ್ ಲೆಟರ್ d ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿದ್ವಿ, ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಡೆಲ್ಟಾ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿದ್ವಿ, ಎವರೇಜ್ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಇಟ್ಸ್ ದ ಲಿಮಿಟಿಂಗ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಈಸ್ ದ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ವೆಲಾಸಿಟಿ. ಲಿಮಿಟಿಂಗ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಈಸ್ ದ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ವೆಲಾಸಿಟಿ. ಬಟ್ ಡೆಲ್ಟಾ ಆರ್ ಯು ನೋ ದಿಸ್ ಒನ್, ಡೆಲ್ಟಾ ಆರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಐ ಕ್ಯಾಪ್ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ವೈ ಜೆ ಕ್ಯಾಪ್. Now you substitute vector v is equal to limit of delta t tends to 0, delta x I plus delta y j cap divided by delta t. This is split now. Delta x by delta t. Limit of delta t tends to 0, delta x by delta t I cap plus limit delta t tends to 0, dy by dt. Now this is equal to, ಇದನ್ನ ಹೀಗೂ ಬರೆಯಬಹುದು, ಇನ್ನೊಂದು ಸ್ಟೆಪ್ ಹೀಗೆ ಬರೆಯಬಹುದು, dx by dt I cap plus dy by dt into j cap. Now here dx by dt I cap means dx I cap. Clear ಮಾಡಿದ್ವಿ. That is px is equal to, this is px is equal to delta x by delta x by delta dt के dx plus vy j cap equation. This is the expression for the instantaneous velocity. This is instantaneous velocity along x-axis. This is instantaneous velocity along y-axis. Now its magnitude is p is equal to under root of vx square plus vy square. Equation number 4. And direction is vy by vx. What is the direction of the velocity? Direction of the velocity along the direction of the delta. Along the direction of the delta. Direction of the velocity is always along the direction of the displacement. Okay. Now, when we express the velocity, at that time, you got the two types of velocity: average velocity and instantaneous velocity. When you calculate the average velocity at that time, delta t is not tends to 0, and delta r is also not tends to 0. This graph for average velocity. These two graphs are instantaneous velocity. Now this is instantaneous velocity. This is the change in the displacement. You draw the tangent to this one. This is the velocity. This velocity is resolved into two components. Now come to the resolution of a vector. Very important. Resolution of a vector. Now resolution of a vector. Now one of the component along this direction, one of the component is horizontal, vertical. This is theta. Theta side component is always cos component. Therefore, this resolved into two component. One is v cos theta, one is v sin theta. The instantaneous velocity is resolved into two components. One is along the horizontal, another one is vertical. Along the horizontal, v cos theta. Along the vertical, v sin theta. This is about position vector, displacement vector, velocity vector. In the case of velocity vector, about the average velocity and about the instantaneous velocity. When a particle moves with two dimensions. Now see here, what are the three important equations? Here, this is position vector expression. This is magnitude of the position vector. This is direction of the position vector. Similarly, for displacement vector, this is expression for the displacement vector. This is expression for the displacement vector. This is for magnitude. This is for direction. Three equations. Again, in the case of velocity, there are three equations for average velocity. Average velocity, px I cap plus vy j cap, one expression. This is possible. Now this is for magnitude, equation number 2. This is for direction, equation number 2. Again, you have got three equations for average velocity. Similarly, for instantaneous velocity, this is one expression. This is for velocity expression. How you got after the and this is for magnitude of the velocity. Now this is for what you say direction. Wherever d comes, dx by dt, dr by dt. So here dx by dt instantaneous velocity along the x-axis. dy by dt instantaneous velocity along y-axis. dr by dt indicate the instantaneous velocity along either it may be 2 dimension, either it may be in the 3 dimension. This is the 3 important points how to take here. This is point. Now you carefully observe and you carefully express the expression for the instantaneous velocity, average velocity, 3 equations. Here also again you got 3 equations. And position vectors, again 3 equations. Position vector expression, magnitude, and its direction. This is pointer. Now it is very carefully observe and write the expression when a particle move with a, what you say, that is a 2-dimension motion. Yes, dear students, I want once again request all of you become a subscriber for our physics channel. How you subscribe? You first you have to press the subscriber red button and you press the bell button. You become a subscriber for our physics channel. Okay, if you like this video clip, you like it, you press the like. What's this point? Yes, thank you. It is the motion of a particle in 2 dimensions. Next, in next video clip, I want to discuss about acceleration vector. Because when a particle moves with a that is 2-dimension motion, in this video clip, I want to explain position vector. I want to explain displacement vector. I have explained velocity vector. In the case of velocity, average velocity and distributed velocity. Okay, thank you.